Hello, this time we would like to explore the conditional statement and its parts. So to begin with, we have this. We are interested in expressions of the form if something, then something else. Just to essentially the rules, rules that we write. So here I have an example. If I get an A in discrete math, then I pass discrete math. Kind of codifying a rule, essentially, here. Now let's look at the components, right? The statement is molecular, right? I'm going to signal those components with letters, just for simplicity, where I would say the first one would be I get an A in discrete math. And the other one would be I get, or I pass the class, sorry. Okay. Now in symbols, it would look like this. P implies Q. If P, then Q. Now, the parts of this implication have their own names. We would say that P is the antecedent, what is to the left of it, and the consequent. Now, something that I should really remark is in terms of the truth values associated with this. Well, let's see. When the conditional P implies Q is true, making that assumption, the truth, and I'm going to put it in space, right? The truth of the consequent Q is necessary for the truth of the antecedent Q. Establishing this necessity, right? Now, inverting things a little bit, we would say that the truth of the antecedent P is sufficient for the truth of the consequent Q. Now, I think it's a little easier if we see it in an example. That's just to convince ourselves, right? How would we put it? Well, getting an A in discrete math is a sufficient condition of me passing the class. Right. Secondly, passing the class is a necessary condition of getting an A. With this, we finish the parts of a conditional statement.